Today's lesson is on polynomials. We're going to be talking about some vocab and also performing the operations of addition and subtraction. Okay, so first of all, some definitions. A monomial is an algebraic expression consisting of just one term. And I've listed out some examples of what a term would be. So 3x, 5y, 7xyz, those are all monomials. So a single term expression. A binomial is an expression that has two terms. So 3x plus 7, 2y minus 6z, 5rst minus 2xy. Those are all expressions with only two terms and therefore binomials. A trinomial has three terms. 5x squared plus 3x minus 9 is an example. 8x cubed y minus 5x squared minus 7y is another example. So again, it has three terms. A polynomial is an algebraic expression involving the sum or difference of many terms. I put many in quotation marks because technically a monomial is a polynomial. A binomial is also a polynomial. A trinomial is a polynomial. But also if we have 4 terms, 5 terms, 6 terms, a million terms, those would all be polynomials. So poly is just the prefix means many. Okay, so first of all, we need to make sure that we do not have any fractional or negative powers on variables. We also need to make sure that there's no variables in the denominator, and we can't have a square root of a variable. If we violate any of those conditions, then technically we do not have an algebraic term, and therefore it's not a polynomial. So looking at these examples, I just want to kind of decide whether or not it is a polynomial expression or it's not a polynomial expression. So the first one we're going to take a look at is 5x. We're trying to decide, whoops, sorry about that. Is that a polynomial or is that not a polynomial? So notice that we have a variable in the denominator. This is not okay. So we would determine that this one is not a polynomial. 4xy minus 3. 4xy is a term, and it does not violate any of those conditions. Minus 3 is a constant, also considered a term in algebra. So therefore, this one is fine. It's a polynomial. 6t to the negative third power. We are not allowed to have a negative exponent because that would actually mean 1 over t. Since t is in the denominator, it is not a polynomial. Negative 5. This is just a constant value, so it is a term and therefore a polynomial. 64t to the fifth u to the 1/2 v. We have a fraction in an exponent that actually indicates a root. So the square root of u is not allowed, so therefore it is not a polynomial. And the last example, negative 8 square root of x. Again, we have a variable underneath square root, so therefore it is not a polynomial. So now that we've talked about some definitions, let's go ahead and start to either add or subtract these polynomials together. We want to make sure that we're always combining like terms. So a like term is something that has the same variable and the same exponent on that variable. Okay, so taking a look at the first example, we have 7x squared minus 5x plus 3. And we're adding on the polynomial 9x squared plus 3x minus 8. So again, we want to look for some like terms. So the first set of like terms that I notice is 7x squared, and we're adding on 9x squared. So that would give me 16x squared. Okay, taking a look at the next set of terms that are like, I have negative 5x, and we're adding it on to positive 3x. So if we add those two like terms, we would get negative 2x. And then the last set of like terms are our constants. We have positive 3, and we're adding on negative 8. So that's going to give me negative 5. Notice that we did not change any exponents. We were just adding the coefficients of those terms together. So this is our final answer, 16x squared minus 2x minus 5. Okay, for example number 2, I'm going to change color, and I'm going to go with blue this time. We are still adding these two polynomial expressions, but this one again, I need to make sure that I'm just combining like terms. So there may be some items that are not like, and therefore we just need to bring them down into our final answer. For instance, 6x cubed is the first term in this first polynomial. However, notice there's no x cubed term in the second polynomial. So this 6x to the third has nothing like to combine it to. So we're just going to pull it down. So 6x cubed. Okay, the next highest degree is positive 3x squared. And notice we are adding that on to 7x squared. So those are like terms, so we can combine them. So 3x squared plus 7x squared gives me 10x squared. The next highest degree is the x variable. It has a degree of 1, so it has a power of 1, even though there's no power written on it. And there is nothing else in those expressions that are like that. So I'm just adding negative x to my final answer. Okay, and the last set of like terms, we have negative 2 as the constant, and we are adding negative 6 to it. So if we add those two like terms, we would get negative 8. Notice that I went from two trinomials to a polynomial with 4 terms here because, again, that 6x cubed had nothing like that we could combine it with. And same thing with the linear x term. So the negative x, again, had no like terms, so we just brought it down. So our answer is a polynomial that has 4 terms, whereas when we were looking at the original example, we were trying to add 2 trinomials together. So again, just be careful that you only combine like terms together. Okay, these next examples are very similar to the last, except these are subtraction examples rather than addition examples. So what we need to make sure is that we are subtracting every item in the second polynomial from the first. So the easiest thing to do is to distribute the negative sign so that you don't confuse whether we're adding or subtracting as we move through. So I'm going to take this first example and I'm going to distribute that negative sign to every single term in that second polynomial. What this is going to do is it's going to change every single sign in that second polynomial. So the first polynomial is not changing, so I'm just going to bring that down. 7x squared minus 5x plus 3. Since we're subtracting, if I distribute that negative, I can then just think addition. And negative times 9x squared would be negative 9x squared. Negative times 3x would be negative 3x. and negative times negative 8 would be positive 8. Now that I've rewritten this, I don't need to worry about remembering that we're subtracting. Now I can just think we're adding exactly like the last examples. So we have like terms. Let me change color real quick. Of 7x squared plus negative 9x squared. That would give me negative 2x squared. The next set of like terms, we have negative 5x. We're adding negative 3x to it. That gives me negative 8x. And the last set of like terms, we have positive 3, and we're adding positive 8. It gives me positive 11. Okay, there are no more like terms that we could combine, so this is our final answer. Okay, taking a look at example number 2, I'm actually going to erase the slide here, so if you would like to write down anything from example 1, please do so at this time. I kind of invaded the space for example 2, so I'm going to clear that slide. And hopefully I gave you enough time to do that. Okay, so for example 2, again, I'm going to distribute that negative sign to each item in the second set of parentheses. So that second polynomial, we're distributing that negative to all 3 terms. The first polynomial is not changing, so I'm just going to pull that down. 6x cubed plus 3x squared minus 2. And once we distribute that negative, we are going to be adding the polynomial. Negative times 7x squared is negative 7x squared. Negative times negative x is positive x. And negative times negative 6 is positive 6. All right, again, we're looking for like terms. I'm going to switch color. If we look, 6x to the third, there is nothing like it in the second polynomial. There are no x cubed terms in that second polynomial. So I'm just going to bring that down. 6x cubed. The next set of like terms, I have positive 3x squared, and I'm adding on negative 7x squared. That gives me negative 4x squared. The next term, there's a positive x here, but the first polynomial has no x terms. So I'm just going to pull that down. So plus x. And then we have negative 2. And we're adding on positive 6. So we get positive 4. Again, checking that for any more like terms. They are all different. So therefore, that is my final answer. Okay, with this next slide, we're going to kind of put it all together. So we're going to add or subtract the polynomials, but then also classify the answer according to what type of polynomial it is, if we have a special name like monomial, binomial, or trinomial, or if we just want to classify it as a polynomial. We want to identify the coefficient of the highest degree and state the highest degree. We've talked about degree in a previous lesson, but just as a little refresher, degree is the highest exponent of the term. And if a term has more than one variable, you would add the exponents together to get its degree. Okay, let's take a look. So the first example, we have 5x squared. Whoops. Okay, 5x squared, and we're adding on negative 4x squared. That is just going to be 1x squared, or just x squared. I technically do not need to write the 1 in front. The next set of like terms, we have negative 2y, and we're adding on negative 9y. So if we add those two together, we get negative 11y. The exponents, we have x squared, so that has an exponent of 2, and y, I'm going to go ahead and write the first power on that. So the highest degree is 2, because that's the highest exponent. And the coefficient of that term is 1. The last thing we want to do is classify this as a monomial, binomial, trinomial, or just in general polynomial. Since this has 2 terms, it would be a binomial. So it's a binomial. It has a coefficient of 1 on the highest degreed term of 2. Okay, I'm going to switch colors to work on the second example. We have the first set of terms. Oh, before I get started with combining like terms, this is a subtraction problem. So we are going to distribute that negative sign to every term in that second set of parentheses. Okay, so 6x squared y squared plus 8x squared y minus 4. Again, that first expression is not changing, but now we're distributing that negative sign through to every term in the second polynomial. So negative times 10x squared y squared would be negative 10x squared y squared. If we multiply the negative times the next term, we would get positive 2x squared y. Multiplying the next term by negative, we would get negative 3xy squared. And multiplying the negative times the positive 3, we would get negative 3. So notice, again, every single term in that second parenthesis, in that second polynomial, switched signs. Okay, now we're ready to combine some like terms, and I'm going to switch colors again just so that they're easier to see. So we have 6x squared y squared. We're adding on negative 10x squared y squared. That is going to give me negative 4x squared y squared. Looking at the next set of like terms, I have 8x squared y, and we're adding on 2x squared y. So that is going to give me 10x squared y. Picking out the next set of like terms, I see a singleton, negative 3x y squared. I'm just going to bring that down because it does not have a like term in that first polynomial to go with it. And then we have the constant terms. So we have negative 4, and we're adding on negative 3. So that's going to give me negative 7. If we count up the number of terms this expression has, it has 4 terms. So it does not have a special name. We're just going to call it a polynomial. This first example is still a polynomial, but specifically it's a binomial. It has a special name because there's 2 terms. So technically it's still a polynomial, but it has a more specific name for it. Okay, this one does not, so we're just going to stick with polynomial. Okay, the highest degree, if we take a look at this first term, we see x squared y squared, so we would add those 2 exponents together. So the highest degree is 4, and its coefficient is negative 4. Notice, guys, we always write these in descending degree. Again, we talked about that before, but we want the highest degree to be written first, followed by the next highest degree. Notice that these two both have degree of 3 because we have x squared y to the first. So we would add those exponents. We get degree 3. Same thing over here. This is also degree 3. We add the 1 exponent on the x to the 2, the exponent on the y. So these both have degree of 3. And then this has degree 0 because there is no variable on it. Okay, the last slide in today's lesson is a you try. It's very similar to the last one that we did together. So take a look, see if you can find the answers to those examples, and pause the video here, work those out, and then unpause the video when you're ready to reveal the answers. Okay, hopefully you've had enough time to look at those. When we added these two polynomials together, we get 5x squared minus 10x plus 5. It is a trinomial because it has three terms. The highest degree is 2, and the coefficient of that highest variable exponent is 5. Okay, the second example, we were subtracting, so hopefully we remember to distribute that negative sign through. So the first polynomial does not change, but the second polynomial, we distribute that negative and get negative 5r cubed s squared minus 6. And so when we combine like terms, we get negative r to the third s squared minus 9. That is a binomial. It has two terms. The degree is 5. We add the exponent of 3 to the exponent of 2 to get that degree of 5. And the lead coefficient is negative 1, again, because there's no number in front of that r cubed s squared other than the negative sign. So again, that is inferred that it's negative 1 times r cubed s squared. So again, that coefficient is negative 1. Okay, this concludes the notes on adding and subtracting polynomials along with some vocab for polynomials.